Welcome back. We're going to continue today looking at perfect competition by focusing on how to graph perfect competition. So the goal is to be able to identify how to graph perfect competition and identify whether a competitive industry has a profit or a loss by looking at the graph. We start by talking about the fact that with perfect competition, we're going to be drawing what are known as side-by-side graphs. You'll have one graph that is the industry graph, that's the one represented on the left, and the individual firm graph, which is the one on the right. Remembering that the industry has many firms. So the industry supply curve is the sum of all of the supply curves for the individual firms, and that interacts with the overall market demand to determine a price. That price is then transferred to the firm. So we find the intersection of supply and demand on the left, and we essentially draw a line horizontally across the industry, from the industry graph to the firm graph. That is our marginal revenue curve, it is our demand curve, it is our price curve. They're all one and the same. And we see where that intersects the marginal cost curve. That tells us our optimal output, and then we will compare that price to average total cost at the optimal output to determine if there's a profit or a loss. So again, just to review, we know that profit is equal to total revenue minus total cost. And we know that if we divide both sides by quantity, we'll get profit per unit is equal to total revenue divided by quantity, which we determined as marginal revenue, or average revenue, which is equal to price. And we found that total cost divided by Q is average total cost. And so we know that profit per unit is going to be equal to price minus ATC. So total profit will be price minus ATC times Q. Now, if you get lost in the math, not a huge deal. Big thing is keeping in mind this equation in red at the bottom. That's what we're going to use for pretty much all market structures when we graph them to identify total profit. So we can look at some examples. In this example, the firm is facing a market price of $18. That's the marginal revenue equals price equals demand. It intersects marginal cost at a quantity of 5. So we find that MC equals MR point, and we go down to the horizontal axis to find the quantity. And we notice that the price at a quantity of 5 is greater than the average total cost at a quantity of 5. How much more? $3.60 more than the average total cost. So there's that vertical distance right here. And so total profit is this vertical distance, this is the profit per unit, times the number of units that we sold, and that gives us our total profit. Another way of thinking about this is total revenue is price times quantity. So it's $18 times 5. So this large rectangular area is total revenue. Total cost is average total cost times quantity. So we know the quantity is 5. So we go up till we hit the ATC curve, and then that creates a box for us. And we can see that that box of total costs is less than the total revenue box. So when revenues are greater than costs, we have a profit. So visually, we can see that when price is greater than ATC, we have a positive economic profit. If the price were $10, we'd have an economic loss. Profit would be negative because market price at $10 tells us marginal revenue equals demand equals price. We find where MR and MC intersect. That's at a quantity of 3. At a quantity of 3, ATC is greater than price. And so the difference between price and ATC will be the loss per unit times the number of units, gives us this sort of brown peachish shaded box. That's how much total loss the industry is experiencing. So in summary, when price is greater than average total cost, we have a profit. When price is less than average total cost, we have a loss. And when price and average total cost are the same, we have what's known as the break-even point. The break-even point is where profit is 0 or normal. So anytime you have this sort of confluence or intersection of marginal revenue, marginal cost, and average total cost, at the same point, you have profit of 0. One question we should ask ourselves then when it comes to profit is, should the firm operate if there's a loss? I mean, obviously it should operate if there's a profit, but what if there's a loss? And the answer is maybe. The firm might want to operate at a loss, but it depends. And what depends, the thing that depends the most is the variable costs the firm faces. We know the firm faces fixed costs that have to be paid, but they're sunk. And we talked about sunk costs. We don't care about sunk costs. So yes, there are costs that have to be paid. If I shut down and don't operate, I'll be at a loss, but it doesn't matter. I can't get those costs back. So we don't make decisions on fixed costs. We only make decisions on variable costs. And so the question we have to ask ourselves is, can I sell my product at a price that is as much as it costs me to make the good? If the answer is yes, then we'll stay open. If I can earn more than it costs to make the last good I made, then it's worth operating at a loss. If not, then we should close. So the shutdown price is the point at which price is less than average variable cost. The firm will not operate if the average variable costs are greater than price. If, however, the price is greater than average variable costs, then it's worth operating, at least in the short run. In the long run, we'll probably close. But at least in the short run, it's cheaper to operate at a loss than it is to shut down entirely and close my doors. And we'll walk through an example here in just a second. But to show you that this is in the real life, in the Wall Street Journal back in 2023, there was an article about Ford and electric vehicles. And in that article, it said that Ford believed that its revenue minus variable costs was expected to approach break even by the end of the year. So they were operating at a loss. They hadn't broken even yet. They weren't earning a profit, but they did expect in the near future to be able to get to a point of a break even. And so it justified staying open. There are times when it makes sense for firms to operate even when they're losing money. So here's an example of a shutdown. Let's assume the price is $9 for a good, and we're producing 10 units. That's the optimal output. And we have fixed costs of $500. And we have a minimum average variable cost of $10. So in this situation, our total revenues are $90. Our variable costs are $100. That's $10 is the minimum average variable cost times the 10 we're producing gives me a total variable cost of $100. So the profit I'm working at here is $90 in revenue, $500 in fixed costs, $100 in variable costs, leads me to a loss of $510. This is a situation where I should shut down because if I shut down, I lose $500. I lose my fixed costs. If I operate, I lose $510. And so if I'm going to maximize my profit, that means having the biggest positive profit possible, but also the smallest loss possible. I'd rather lose 500 than 510. I'd rather not lose anything, but if I'm going to lose money, I'd rather lose 500 than $510. So in this case, it is best for us to shut down. If, however, the price was $11 at a quantity of 10, fixed cost of 500, our minimum average variable cost was $10. Then in this situation, my total revenue is $110 coming in. My costs are still the same, but in this case, my profit is a negative $490. I'm losing $490, but the shutdown loss is $500. Basically what I'm saying here is I'm covering all of my variable costs, and then I can take some of what's left over and put them towards my fixed costs. That leaves me in a better situation currently than if I were to shut down entirely. I would lose more by shutting down than by staying open. So anytime the price is greater than the minimum average variable cost, there will be a loss, but that loss will be smaller than if we closed our doors permanently. And there are companies that deal with that, which we'll look at in just a second. But on this graph, there's two important points that you need to be able to identify for an individual firm in perfect competition. The break-even point, which is where profit is 0. That's when price equals ATC. And then our shutdown point, where price is equal to the minimum of average variable cost. So those 2 points are going to be very important because you can get questions that will ask you, should the firm operate? And as long as you're in that zone between P1 and P2, the answer in the short run is yes. We should operate even though it's at a loss, because that loss is smaller than shutting down. Another thing that we should recognize then is that the marginal cost curve is the supply curve above the minimum of AVC. Remember the supply curve, way back in a previous unit, we talked about how supply was telling us the minimum price I need to receive in order to produce. Well, the minimum price I need to receive in order to produce is what it costs me to make the item. And what it costs me to make the item is the marginal cost. So our marginal cost curve is the supply curve. And that should also make a ton of sense because we always operate where supply and demand intersect, ideally. And so if the marginal revenue curve is the demand curve, and we go where marginal revenue and marginal cost intersect, then marginal cost has to be the supply curve. So any point above the average variable cost curve along marginal cost, that is our supply. And I would get in the habit of every time I see a marginal cost curve, I would just put MC equals supply. That'll be super helpful, especially when we get into monopoly, to get in the habit of saying marginal cost equals supply, because it is, as long as it's above the shutdown price. Now, what are some firms that deal with shutdown questions? Amusement parks oftentimes have to deal with this question of, do we operate or do we shut down? Very few people like to go to an amusement park when it's snowing outside and it's 20 below. And yeah, the roller coasters are fun, but is it really all that fun when it's so cold? And the answer is, for some people, yes, but for most people, no. And that's why, generally speaking, amusement parks are shut during the winter times, and certainly during the week during the winter, because they simply cannot generate enough ticket sales to justify all the costs associated with opening up and starting all the rides. The same with stores like Rita's Frozen Ice, where many Rita's locations will close in the fall and reopen again in the spring. They're still paying their lease, so they're losing money in those months that they're closed, but they're losing less money when they're closed than if they were to open. If they open, they have to pay for the utilities, the ingredients, the workers, and if you only have 1 or 2 people coming in during the day to buy frozen ice, and yet you're paying someone to work for 8 hours a day, you're going to lose more money than if you just paid the rent. So this is a real life issue that some companies do address. Next time we meet, we're going to talk about the shift from the short run, when you operate potentially at a loss, into the long run. And I will talk to you then.